So we wouldn't do a very good job of, um, sorry, we wouldn't do a very good job of energy savings if we did not know how much energy a building uses in the first place. So that's what we do benchmarking for. We have a facility. We want to save some money there, but we need to know, well, how well is this facility doing in the first place? So that's called benchmarking. Then remember, we go through the whole cycle, we make some energy changes, we measure our energy and power use over time, and then we go through and we say, oh, well, what is our index now, or how are we doing now compared to before we made these changes? So the first step to any energy management strategy is benchmarking. In benchmarking, there's a few ways to do it. I'm going to tell you two of them. Two of them that are very popular here in Canada and Ontario. So EUI is the Energy Use Index, and that's a very popular way of benchmarking in Ontario or in Canada. In Canada, we use something called Portfolio Manager. It's free to use. It's a government tool. And some of you might end up working for the government in Natural Resources Canada. They have some co-op and full-time jobs in energy. They maintain this thing called Portfolio Manager. It's free to use, and you just have to make sure that you put your data in it, then you can see everybody else's data. So Energy Use Index is a very basic measure of a facility's energy performance. It basically says how many megajoules of energy do you use each year, divided by the area of your conditioned space. So when you do that calculation, you can see, well, where am I compared to other buildings? So for example, an office building is around 900 megajoules per meter square per year, but a fast food restaurant is 2,000. Now, if your office building is performing at 2,000, then you can see very clearly that, oh no, we have a problem because I'm not running all those fast food fryers and everything, so I shouldn't be up in the 2,000 range. Education and retail stores tend to be even less than office buildings, so 750. That's probably because office buildings sometimes have kitchens in them. Kitchens are actually pretty expensive to run. Mostly it's because of the dishwashers, actually. Churches are only around 320. Why is that? Well, because they're usually not occupied every single day, so that energy use goes down quite a bit. Again, vacant buildings are as low as 160. Healthcare is quite high, 1,800. So you can see that this energy use index is quite interesting, and you can see around where your buildings lie in it. Healthcare is high because of a lot of equipment, machineries, and also because healthcare runs around the clock, 24 hours a day, whereas your office building, for example, would not, and even your restaurants would not. So that's quite interesting. Calculating the energy use index is quite straightforward. It's just the total energy that you use divided by the area. And the energy, usually you're using various types of energy in one facility. In this example, you're using electrical energy and natural gas. You need to figure out, well, how many megajoules per year of each of these do we use? So you get that megajoules per year of energy, add them up, divide by the area of your building. Again, it's just a general benchmarking tool, and you're around 480. So this is around kind of like a warehouse. This is a pretty low energy use index number. You're not up high like 2,000 like a restaurant or a hospital, and you're not even as high as an office building. So I would assume an energy use index of 480 should be around about a warehouse kind of facility. But let's say you're comparing this to other warehouse facilities, maybe another one that you run in a different city is only at 200 and yours is at 400, then you can obviously figure out what's different between them, find some energy management savings. So that's one benchmarking tool. I do have a picture here that just illustrates to you that you can compare. So this index allows you to compare between different buildings. So note here the units. So here, when I'm talking about restaurants and hospitals, and I was saying that they're around 2,000, well, I was talking about metric units. This chart, this is the nicest chart that I can get on the internet without logging on to our government benchmarking tool, but this one is imperial. So sadly, these are not comparable numbers, but I'm just showing you that this energy use index is used to compare between different types of buildings. So that's what it's useful for. So benchmarking energy factor is another way that you can do that, that you can benchmark, but it accounts for only the energy that the facility has control over. So it's a little bit more complex of a calculation. It removes all of the physics and it benchmarks against each other by comparing only the effects of the operation. So what you would do is you would do your energy use index first, and then benchmarking energy factor is a little bit more complex, where it takes out, let's say, some of the costs associated with the building that you can't change, and only looks at the costs of, say, doing the production operation at a factory, for example. So I want you to know what it is, but we're not going to do any calculations with benchmark energy factor. Another one that is used very commonly here is the energy cost index, but it has a lot of limitations. I don't really love it. The energy cost index says it's the cost of the energy you used in the year divided by the meter squared of conditioned space. So basically it's the cost, total cost. So it's the dollar value over the area over meter squared. Great, it's easy to calculate, it is very useful, and you want to do this for your facility. You want to do this before you make your energy savings opportunities, so that you know, well, how much am I paying per meter squared? But the problem with this is it does not scale, does not compare very well. So the cost per meter squared of your facility will not compare to any others, in the sense that you can't say, oh, that's like a warehouse or that's like a hospital. It's really only useful for yourself to say, hey, at the start of the program, I was paying $13 per meter squared. Look, I made all these energy savings and now we're only paying $10 per energy squared. Therefore, pay me $100,000. That's basically what it is useful for. So the calculation is just saying the energy costs in dollars each year. So we need to take our electricity, cost of electricity, cost of natural gas, convert that into dollars per year. So the dollars per year go on the numerator and the area goes on the denominator, and that's how you get your dollars per year. But there are no useful tables, but we would use this just to see how well we did in our energy savings.